Come on, my dears. Today we will finish the only illustration left out in the theoretical part, that is last illustration, and along with that we will finish all the MCQs from exercise. Okay. First of all, you please read this statement of illustration number 13. What have they asked? Maximum potential or maximum induced EMF. What was the formula for that in case of AC generator? The formula of alternating voltage was V equals to Vm sine of omega t. Remembered? But in that, what was Vm? Vm was maximum voltage or maximum induced EMF. And it is given by this formula Vm equals to NAB omega. Fine. Can you give me identification of each quantity? Come on, what is capital N? Total number of tons which they have given 50. What is capital A? Area of 1 ton which is 2.5 meter square. What is capital B? It is uniform magnetic field which have they given 0.3 Tesla. And what about omega? Angular speed they have given 60 radian per second. My dear, sometimes they may give only frequency. Then in that case you should write omega equals to 2 pi f. Suppose they are giving periodic time, then you can write omega equals to 2 pi upon capital T. Got it? Right now they have given this angular frequency directly 60 radian per second, or angular speed you can say. Fine. And now this answer comes out to be 2250 this many volt. Suppose they ask this answer in kilovolt, then when you go from volt to kilovolt, you are supposed to multiply by 10 raised to minus 3. So if you do that here, then you will get answer 2.25 kilovolt. Got it? Fine. What about current? Current formula according to Ohm's law. Current equals to voltage upon resistance. Here you are asked to find out maximum current. So I am writing here IM. M stands for maximum. Then here also you should take maximum voltage. Fine. That maximum voltage we have found out 2250 volt. What about resistance? They have given 500 ohm. This answer comes out to be 4.5. Unit of current is ampere. You must write capital A and don't put any full stop. Okay. In the second case, they have asked what is the magnetic flux linked with the coil when there is no current through the coil. Let us find out. No current means I is 0. Correct? When current is 0, naturally voltage also will be 0. But what is the formula of alternating voltage? V equals to Vm sine of omega t. And that equals to 0. Find out sine of omega t from here. Take this down. So it is 0 upon Vm, that is 0. If sine of omega t is 0, it means to say omega t must be 0 because sine 0 is 0. Correct? Fine. So omega t is right now 0. Now they have asked magnetic flux linked with the coil. What is the formula? NAB cos theta. Speak out again. NAB cos theta. Okay. What is the formula for theta? Theta equals to omega into t. Correct? Fine. Now tell me, number of turns is 50. Area of 1 ton is 2.5 meter square. Magnetic field is 0.3 Tesla. Omega t value is right now 0. Omega t is 0. Now cos 0 is 1. Remaining answer is 37.5. Unit of magnetic flux is Weber. What is the symbol? Capital W small b. Correct? Now in the third section they have asked magnetic flux linked with the coil when maximum current passes through the coil. Let us find out. When current is maximum, naturally voltage also will be maximum. Fine. What is the formula for alternating voltage? V equals to Vm sine of omega t. And that equals to maximum. Fine. Now see, this Vm is constant and then also this left hand side is maximum, it means to say that this remaining function must be maximum. So sine of omega t must be maximum, but what is the maximum value of sine or cosine function? It is 1. So here sine of omega t must be 1, but you know sine pi by 2 is 1. So this omega t angle must be equal to pi by 2 radian, pi by 2 radian, fine. Now recall the formula for magnetic flux, capital phi equals to NAB cos theta, theta equals to omega t, theta equals to omega t, and omega t is right now how much? Pi by 2. When theta is pi by 2, you know cos pi by 2 is 0, the whole product will be 0, phi equals to 0, correct? Come on my dears, let us now begin with MCQs from this chapter. Some of you know what they feel, that these are the MCQ questions, I must mug it up, then I will remember them, then I will be getting marks accordingly. It is not like that. See, even if you might be knowing the solution of particular MCQ, but the moment they will change the values inside, then you will be getting wrong answer if you have not really understood that solution. Please try to give enough importance to these MCQs also. And one thing more, some of these MCQs are really worth understanding, quite difficult one, longer than the explanation of numericals also sometimes. So they will be very much helpful to you in the preparation for JEE and NEET. So please give enough importance to these MCQs also, okay? Now please kindly read the first statement. Come on, have you read it? Now tell me, what is given to you? We are given a square frame which is moving towards right hand side with a velocity say v, fine. Now in the region where this square frame is moving, you know what is the situation given to us? In half of this frame there is a magnetic field perpendicularly outward. That's why I have shown them by symbol of dots. In the remaining half, the magnetic field is perpendicularly inward. Okay? Now tell me, we are asked to find out resultant induced EMF in this loop. Let us find out. You know there are electrons in this wire, and along with the loop, they also acquire velocity towards right hand side. And you know whenever any charged particle moves in a magnetic field, it will experience magnetic force. So far electrons are concerned, which are negatively charged particles, you know formula of magnetic force, it was vector Fm is equal to E into vector B cross vector V. Come on. If you are talking about this side, then where the electrons will get displaced depending upon direction of magnetic force. But what is the direction of magnetic force? Direction of magnetic force is vector B cross vector V, in the direction of vector B cross vector V. Now tell me, for this side, because it is moving this way, correct? So velocity is towards right hand side, magnetic field is perpendicularly outward. So situation is like this. This is vector B, this is vector V, this is vector B, this is vector V. Now tell me, you want direction of vector B cross vector V, it will be vertically upwards this way. So direction of magnetic force exerted on electrons in this wire is vertically upwards. So what will happen? This end after losing electrons will become positive, and this end after gaining extra electrons will become negative. That is how some EMF is developed between these two ends. Let it be capital E. Fine. What about this side? Correct? Come on. For this side, what will happen? Tell me. For the electrons in this wire, they also have velocity towards right hand side, but magnetic field is perpendicularly inside. So this is vector B, this is vector V. Now you want vector B cross vector B, vector B cross vector B. It is right now, come on, vertically downwards. So direction of magnetic force exerted on electrons in this wire is vertically downwards. So what will happen? This end after losing electrons will become positive. This end after gaining electrons will become negative. And here also length is L, this length is also L. So same magnitude of induced EMF you will get here also. Now what I have done, equivalent to this situation, I have shown two batteries here. Now this wire behaves as if it is a battery of EMF E, and that battery I have shown here, and likewise for this wire also I have shown the battery over here. Now tell me, for the battery which represents this wire, the lower terminal is positive and upper terminal is negative. And here for this wire, lower terminal is negative, upper terminal is positive. Lower terminal is negative, upper terminal is positive. Okay. Now tell me, what do you find here? See, unlike terminals are connected together, positive with negative, negative with positive. When unlike terminals are connected together, it is the assisting connection. And in case of assisting connection, remember, resultant EMF is summation of individual EMFs. Summation of individual EMFs. That's why I am putting resultant EMF as E dash, and it is E plus E. E plus E, that is 2E. 2 as it is, what is the magnitude of induced EMF in this case? In case of one wire, it is E equals to BVL. So E equals to BVL. Final answer is 2BVL. Correct? My dear, suppose they give in the entire loop, they give magnetic field say perpendicularly outward in the entire loop. Then whatever EMF is induced here, same EMF with the same polarity will get induced here also. So in this case also, in that case, this battery terminals will be reverted. So in that case, it will be opposing connection. And if it is opposing connection, then E minus E, resultant EMF is subtraction of individual EMFs. E minus E would be 0. Right now, magnetic field is in opposite direction in both the equal halves. Here it is perpendicularly outward, here it is perpendicularly inward. That's why the polarity is like this. And here, because it is assisting connection, we are making addition of individual EMFs, and that's why answer is 2E, where E is BVL. So our final answer right now, it is 2BVL. Got it? Fine. Read now statement of number 3. First of all, number 3, and number 2 is left out. We will take it after number 3. First of all, you read the statement of number 3. Come on, read it. Look, we are given one coil whose surface, whose plane is perpendicular to uniform magnetic field. One coil has its plane perpendicular to uniform magnetic field. Tell me, if the coil is like this, how is the area vector? Area vector is like this. Area vector is like this, correct? Now tell me, this is area vector, vector A, this is vector B. Angle between vector A and vector B is 0 degree because they are in same direction. Fine. What is the formula for magnetic flux? Capital phi equals to NAB cos theta. Instead of theta, I am putting theta 1. Instead of phi, I am putting phi 1. Right now, theta 1 is 0 degree. Put it here. Cos 0 is 1. So it is NAB. Fine. And now tell me, this coil is withdrawn. When it is withdrawn, when it is taken out of the magnetic field, naturally when B will become 0, the magnetic flux also will become 0. What is phi 2 formula? NAB cos theta 2. But right now, because coil is taken out of the magnetic field, B is 0, so this part will be 0. Tell me, earlier there was some magnetic flux linked with the coil, and now there is no magnetic flux. So there is some change in magnetic flux with the coil, and because of that you can expect some induced EMF, and that induced EMF is given by Faraday's law on electromagnetic induction and mathematically minus d phi by dt. What about E? According to Ohm's law, E equals to IR, where I is induced current, R is the resistance of the circuit. Come on, d phi means what? Change in magnetic flux. Change is always final minus initial. Final minus initial, correct? And this time interval we have taken t. Fine. And now tell me, this is induced current. You know, induced current will be induced charge upon time. Induced charge upon time. So I equals to Q by T into R as it is. Now if you take this negative sign inside, then inside order will be changed. Now it will be phi 1 minus phi 2, correct? Fine. Now remember, for whatever time interval there is a change in magnetic flux, for the same time interval there is some charge which is getting induced. So I mean to say these two time intervals are same, that's why you can cancel them, and then you can take this R in the denominator. So formula of induced charge is phi 1 minus phi 2 upon R, correct? Where this phi 1 is initial flux, phi 2 is final flux, R is the resistance. Fine. Have you noted one thing? That this induced charge does not depend on time. Does not depend on time. Come on, initial magnetic flux is NAB. Phi 1 equals to NAB minus phi 2. Phi 2 equals to 0. Phi 2 equals to 0. Correct? Upon R. Now tell me, what is total number of turns? They have given 50. Come on, what about A? A is area which they have given 100 centimeter square. Will it do? No. You must convert it into meter square. Multiply by 10 raised to minus 4. What about magnetic field? They have given 0.02 Tesla. Resistance is 2 ohm. This answer comes out to be 0.005 and unit of charge is Coulomb. The symbol is capital C, no full stop. Correct? Fine. Now read number 2. Number 2. Read it. Come on. According to Faraday's law on electromagnetic induction, what is induced EMF? E equals to minus d phi by dt. Minus d by dt as it is. What about magnetic flux formula? In terms of time, they have given phi equals to 6t square minus 5t plus 1. Come on. Minus as it is. 6 is constant. D by dt of t square, it is 2t. Then minus minus plus, come on, 5 is constant, d by dt of t is 1. Minus plus minus, derivative of constant single term is 0. Now this is minus 6 into 2, that is minus 12 into t plus 5. Minus 12 into t plus 5. Now this shows that this induced EMF depends on time. And that is why you are given time at the end of which you are supposed to find out induced EMF. What is the time they are given? 0.5 second. Okay. Now minus 12 into 0.5 will become minus 6. Minus 6 plus 5, that is minus 1. So this induced EMF is minus 1 volt. If you are interested in finding out the magnitude, then you can take modulus on both the sides. So mod of E will be 1 volt. What about induced current? It is induced EMF divided by resistance. Induced EMF is 1 volt and resistance is 10 ohm. 1 upon 10, that is 0.1 ampere. Got it? Come on, read number 4. Have you read it? The formula for self-induced EMF, remembered from the short note on self-induction, E equals to minus L di by dt. Fine. Now this self-induced EMF, they have given 8 volt minus L as it is. What is this? Change of current. Change means what? Final minus initial. Final current they have given minus 2 ampere minus initial current they have given 2 ampere. What about this time interval? It is 0.05 second. From this you will get the value of L as 0.1 Henry. Remember, whether it is self-inductance or mutual inductance, whether it is capital L or capital M, both of them have same unit, that is Henry, symbol is capital H. Come on, read number 5 now. Read it. We are asked to find out mutual inductance. Recall the formula from theory. Capital M equals to phi 2 upon I1 or phi 1 upon I2. Here I have written phi y upon Ix because current through coil X they have given 2 ampere, and because of that magnetic flux linked with coil Y they have given 0.4 Weber. 0.4 upon 2 will become 0.2 and unit of mutual inductance is also Henry. Come on, read number 6. Read it. Come on. Formula of induced EMF in case of mutual induction, it is E2 equals to minus M dI1 upon dt. If there is a change in current passing through first coil with respect to time, then we will get induced EMF in the second coil. That's why we are putting here mutual inductance. Okay, fine. If here you are writing I2 suppose, then here you should write E1, because here it is I1, I should write here E2 because we are talking about mutual induction. Okay, fine. Now this minus M as it is d by dt of I1. What is formula of I1? They are given I0 sine of omega t. I0 sine of omega t. Now this minus M as it is, I0 is constant taken out, then derivative of sine, it is cos. Derivative of sine is cos. D by dt of sine of omega t will be cos of omega t. Again you should take derivative of this bracketed part, and in that omega is constant, d by dt of t is 1. So it is omega. Now if you take modulus, then mod of E2 will be from minus, it will become plus m I0 omega cos of omega t. But because they have asked maximum value of induced EMF, I should take maximum value of left hand side, and for that I should think of maximum value on right hand side. On right hand side these three values are constants, so you should go for taking maximum value of this. Maximum value of cosine function is 1. 1 into this will be this m I0 omega. What is mutual inductance? They have given 5 millihenry, convert it into Henry, multiply by 10 raised to minus 3. Value of current they have given, come on, 10 ampere. What about omega? Angular frequency they are given 100 pi radian per second. 100 pi radian per second. Leave this pi as it is because in all the 4 options in the statement in the textbook you will find pi. That's why we are keeping pi as it is. Don't put the value, leave pi as it is. And the remaining part you can simplify. Answer is 5 pi that many volt. Come on, read now number 7. Come on, read number 7 now. What is given to us? A network in which there are 3 inductors connected. Come on, between points A and B. each of the inductor has self inductance 3 Henry. Come on. Now we are asked to find out the equivalent or effective inductance between points A and B. See, I am showing you very easy way to get the answer. Here, all these three inductors are connected in parallel. You may not see like that in this diagram, correct? I am showing you easy way. Look, if this point is A, then you should take this also as point A, because they are connected directly without any component between them. In a network, whichever two points which you find connected directly without any component between them should be treated as same point. If this is point A, this also is A, but now this is connected here, so this is also A, correct? Now this point is B, so this is also B, and because this is connected here, it is also B. Got it? Now tell me, this whole network can be considered to be equivalent to this network. Why? Look, for this first inductor, its two endpoints are points A and B. Look here, for this also two endpoints are A and B. For this also, come on, A and B. For this also, come on, A and B. Correct? For these also, A and B. For these also, A and B. Correct? So tell me, how to find these three inductors between these 2 points? They are connected in parallel. And remember, whichever are the laws of series and parallel connection for resistors, same laws are there for series and parallel connection of inductors also. What is the law of parallel connection of resistors? That law was, you had studied in 3rd semester, 1 upon R dash equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 for parallel connection of 3 resistors. Here there is a parallel connection of 3 inductors. So how would you write that law? 1 upon L dash equals to 1 upon L1 plus 1 upon L2 plus 1 upon L3. All these 3 values are, each of them is 3 Henry, correct? So 1 upon 3 plus 1 upon 3 plus 1 upon 3, that is 3 by 3. 3 by 3 is 1. Now take reciprocal, okay? So L dash will be 1 Henry. L dash will be 1 Henry, correct? Fine. Now read number 8. Come on. We are given a coil which is placed, look, perpendicular to uniform magnetic field, correct? When a coil of n number of turns is placed perpendicular to uniform magnetic field, what is the formula for magnetic flux? Phi equals to NAB. Phi equals to NAB. Here it is. Phi equals to NAB. If number of turns is not given to you, you should take 1. What about capital A? Area. They are given 100 centimeter square. Centimeter square will not do. You must convert into meter square. Multiply by 10 raised to minus 4. What about capital B? Magnetic field, they are given 10 raised to 3 Tesla. Correct? Now this answer is 10 Weber. Unit of magnetic flux is Weber. Symbol is capital W small b. Come on, read now number 9. Come on. We are given one aeroplane which is flying in the horizontal direction. So naturally its velocity is along horizontal direction. Moreover, we are given vertical component of Earth's magnetic field, which are shown here. Vertical component of Earth's magnetic field, that is BV. Fine. What is the angle between vector V and vector B? Right now it is, come on, theta equals to 90 degree. In that case, because the wing of aeroplane is flying this way, look here, this way, correct, is going to cut the vertical components of Earth's magnetic field perpendicularly, and because of cutting of magnetic flux, some EMF will get induced across the two ends of that wing, and let that EMF be E. Its magnitude is given by this formula, BVL sin theta. Mind well, this is general formula. The formula which we had studied in theory, it was BVL. At that time theta was 90 degrees, so sin 90 we could take 1, but general formula is this, BVL sin theta. Now here they have given magnetic field in the form of vertical component, so instead of B I am putting BV, and this theta is right now 90 degree. Come on, dictate me all the values. What is the vertical component? 2 into 10 raised to minus 4 Tesla. Come on, this V is the velocity, it is 360 what? Kilometer per hour. No, it will not do. You must convert into meter per second. You know how to convert it. From kilometer per hour to meter per second, you must multiply by 5 and divide by 18. So multiply by 5, divide by 18. Come on, what about L? L is the length of the wing, and length of the wing you are given 50 meter. Theta is 90 degrees, so sin 90 is 1. Simplify. The answer is 1. Unit of EMF is volt. Symbol is capital V, no full stop. Okay. Come on, read now number 10. Have you read it? Look, we have horizontal component of Earth's magnetic field along horizontal direction this way, and one wheel having certain number of spokes is rotating in a plane perpendicular to uniform magnetic field. Perpendicular to uniform magnetic field. In that case, remember one illustration we had done in the same chapter, and in that we had obtained the formula of EMF induced across the two ends of one spoke. And what was that formula? E equals to 1 by 2 B omega L square. You can take that L as length of the spoke also, or you can say it is also radius of the wheel. Radius of the wheel. So instead of L, I have taken the radius R. So 1 by 2 B omega R square. Fine. This magnetic field they have given in the form of horizontal component of Earth's magnetic field, which is BH. What about omega formula? Omega equals to 2 pi F. Omega equals to 2 pi F. Fine. Into R square. Now these 2 will cancel. This BH as it is, pi as it is, F as it is into R square. What about BH? Horizontal component of Earth's magnetic field, they have given 0.4 Gauss. You must convert Gauss to Tesla, multiply by 10 raised to minus 4. I have given you chart, and in that chart you will find all the conversions. Going from Gauss to Tesla, you must multiply by 10 raised to minus 4. Pi value is 3.14. What about frequency of rotation? You are given 120 revolutions per minute. Minute will not do, it is in denominator. 1 minute is 60 seconds. Okay. What about radius of the wheel or length of spoke? It is 0.5 meter and it's a square. Now this answer is 62.8 into 10 raised to minus 6, this many volt, but 10 raised to minus 6 volt is nothing but 1 microvolt. So this answer is 62.8 microvolt. Correct? Thank you. Come on my dears, read MCQ number 11. Have you read it? Look, what we are given in the statement, some part of some network in which we find 3 electrical components. One is resistor, second is battery, and third one is inductor. Okay, fine. Here amount of current passing through this series combination is 5 ampere at a particular instant of time, and it is flowing from A to B, correct, this way, fine. You know, if I amount of current passes through R resistance, then the potential difference developed across the two ends of that resistor is given by Ohm's law, V equals to IR. Voltage equals to current into resistance. Current into resistance. Okay. Current is 5 ampere, resistance is 1 ohm, 5 into 1, that is 5 volt. Correct? Fine. Now, this battery has terminal voltage, they are given 15 volt. What about this inductor? See, this current, when it passes through this inductor, they have said that current goes on decreasing with time. In short, we will get some self-induced EMF developed across the two ends of this inductor. It indicates some sort of potential difference. Let it be VL. Okay. Formula of capital E, remembered, minus L di by dt. Minus L di by dt. Now minus sign as it is. What about self-inductance? They have given 5 millihenry. 5 millihenry. Convert it into Henry, multiply by 10 raised to minus 3. What about di by dt? They have said that current decreases at a rate of 10 raised to 3 ampere per second. Because current decreases with time, I am just putting that rate as negative 10 raised to 3 ampere per 1 second. Okay. Had it been increasing with time, we could have written here plus sign, but right now current is decreasing with time, so I am putting minus sign. Okay, fine. Now tell me, minus minus plus, 10 raised to minus 3, 10 raised to plus 3 will cancel, giving you 5 volt. Okay. Now let us do one thing. Let us just place equivalent batteries. Potential difference across the two ends of resistor, it is 5 volt. So I am placing a battery of voltage 5 volt. But mind well, because current is flowing this way, correct, toward right hand side, for this resistor, the left end will be at higher potential and this right end will be at lower potential. That's why here left end you should show positive terminal and right end as negative terminal, and potential difference is 5 volt. This battery I have kept as it is. Okay, here also negative positive, here also negative positive. This is 15 volt, this is 15 volt. Okay. Now in place of this inductor, I am going to show a battery whose terminal voltage is 5 volt. Fine. So in place of this inductor, I have shown a battery. But tell me, why left end is negative? Listen, this current is entering this inductor from this end, correct? From a given end, if entering current decreases with time, then that end becomes negative and the rest end on the opposite side will be positive. Here also current is decreasing with time, so this end will become negative and this end will become positive. That's why left terminal I have shown negative, right terminal I have shown positive. And what is the potential difference? 5 volt. Now let us do one thing. Just move from A to B. Okay, go this way. Fine. Now tell me, when you start from point A, the potential at point A, let it be VA. Because you are going from positive to negative, potential will decrease. So you should subtract. I am just subtracting 5 volt, minus 5. Increasing then addition, decreasing then subtraction. Go from this point to this point. You are going from negative to positive, so potential will increase by amount 15 volt. Because it increases, I am writing plus 15. When you go from this end to this end, here from negative to positive, potential will increase by amount 5 volt. Because it increases, I am writing plus. How much? 5. and because you have reached to point B where potential we don't know, let it be VB. Okay? But what is asked to us? Potential difference between points B and A. Correct? So let us find out VB minus VA. VB minus VA. It will be 15 plus 5, that is 20. 20 minus 5, that is 15 volt. So VB minus VA has come out to be plus 15 volt. Correct? Now read number 12. It is a very good question. Have you read it? In the statement, they have not said that cross-sectional area of the coil is kept constant. They have not mentioned, but it is required. Okay? Look. Let us first of all find out time rate of change of magnetic flux. Come on. d by dt of a phi. d by dt of a phi. Phi equals to AB cos theta. Where theta, if you take 0 degree, cos 0 is 1. So phi equals to AB. Fine. Now because area is constant, we can take it out. This is cross section area of the coil which is constant, taken out. Left is dB by dt, dB by dt. Because A is constant, because time rate of change of magnetic field is also constant, then this right hand side will be constant. Okay, fine. Now suppose we are preparing one circular ton of radius capital R. For preparing one circular ton of radius capital R, we have to use the wire of length equal to circumference. Circumference is given by this formula 2 pi R, correct? But suppose if we prepare such a capital N number of identical tons, then total length of the wire used will be n times then 2 pi R. That's why I am putting n into 2 pi R. Okay? But because the cross section area of the coil is constant, then radius of cross section of coil will also be constant. So radius of cross section of coil capital R is constant. Now capital R is constant. Capital R is constant. 2 pi R, this part is constant. So L is proportional to N. L is proportional to N. Correct? Fine. Now electrical energy wasted in the form of heat energy per unit time. Energy per unit time, what is it? Power. Because you are talking about electrical energy, we should talk about electrical power. Let it be capital P. You know its formula is square upon R. Is square upon R. But actually R we have used for radius of cross section of coil. So I am just placing here R dash. It indicates resistance of the coil. Okay. Don't get confused between the symbols. Here capital R is radius. Here capital R dash is resistance. According to Faraday's law on electromagnetic induction, what is the formula for E? Minus n d phi by dt whole square upon resistance of a coil, means resistance of some length of the wire. Resistance of conducting wire is rho into L upon A. Just speak out in words. Resistivity into length upon cross sectional area. Now they are taking cross section area of the wire. Cross section area of wire is different. Cross section area of the coil is different. Cross sectional area of wire I am placing a dash. Fine. Now tell me, when you make it square, minus will become plus n square. d phi by dt whole square. Rho as it is. L as it is. What is this? Cross section area of the wire. When you take cross section of wire, it will be a circle. For a circle, don't you know the area? Pi into radius square. Pi into radius square. Mind well, I am putting here small r, which is radius of cross section of wire. Small r is radius of cross section of wire. Fine. And now You can rewrite the same equation like this also. P equals to n square r square upon L. Here it is. N square, this r square will go up upon L. N square r square upon L, I am just separating, into this pi also will go up, pi into d phi by dt whole square, d phi by dt whole square upon rho into L, upon rho into L. Correct? Fine. Now here this d phi by dt is constant. Look, d phi by dt is constant. Correct? So this part is constant. Then resistivity of wire, because you are not changing the material, resistivity will remain constant. So this part is constant. And if you remove this part, then P is proportional to n square r square upon L. P is proportional to n square r square upon L. Remove sign of proportionality, put some proportionality constant into n square r square upon L. Give it equation number 1. And now, this is the power, dissipated power in initial condition, dissipated power in final condition. I am showing by symbol P dash, K as it is, instead of N, because they have said in the statement that number of turns is made 4 times. So instead of N, I am putting 4N. Square as it is. They have made radius of cross section of wire half. So instead of R, I am putting R by 2, it's a square. And because the number of turns is made 4 times, naturally length of the wire also will be 4 times. So instead of L, I am putting 4L. Fine. Because L is proportional to N, when this is made 4 times, this also will be 4 times. Instead of L, I am putting 4L. Now simplify. 1 upon 2 whole square will be 1 upon 4. That 4 will come down. 4 4s are 16. And here 4 square will be 16. So ultimately it is 16 upon 16, that is 1. And rest part is K into N square R square upon L. K into N square R square upon L. Give it equation number 2. From equations 1 and 2, you can see right hand sides are same. So left hand side also will be same. So from 1 and 2, come on, P equals to P dash. Correct? Fine. So dissipated power will be remaining same. Okay? Read number 13. Have you read it? Recall the formula of inductance of an inductor. It was capital L equals to mu 0 n square A by L. Fine. Now this mu 0 n square as it is, what is this? Cross section area of an inductor. When you take cross section area, if it is circular, it is pi into radius square. Correct? Mind well, this is the radius of cross section of inductor. And this is small l as it is. Just find out n square r square from here. Take this small l up, bring mu 0 into pi down in the denominator. Because this L mu 0 pi, everything is constant. Everything is constant. Look, because for 2 cases the inductance is same, length is also same, then this right hand side will be constant. Fine. When n square r square is constant, take square root, then n into r also will be constant. When n into r is constant, come on, n1 r1 equals to n2 r2. n1 r1 equals to n2 r2. n1 number of turns in the first case they have given 100, number of turns in the second case they have given 200, and now they have asked the ratio of radius of cross section of inductor in both the cases. Come on, ratio we can find out this way, r1 upon r2, which they require, it will be 200 upon 100. 200 upon 100, that is 2 upon 1, that is 2 is to 1. Correct? Come on, now read statement of number 14. Look, they have asked about induced charge. Have you remembered this same formula we had derived earlier for induced charge? What was the formula? Capital Phi 1 minus capital Phi 2 upon R. What is this? Initial total magnetic flux. This is final total magnetic flux, and this is the resistance. Fine. Now, initial magnetic flux we know by formula NBA cos theta. Theta is 0 degree, cos 0 is 1, NBA. But later on, why this final magnetic flux I have taken 0? They have said about one ring, correct? But it so happens as time passes on, that ring goes on shrinking, that is, its radius goes on decreasing. And finally, if the radius becomes 0, when radius is 0, cross-sectional area also will be 0. In this formula, if A becomes 0, naturally this part will be 0. So, this magnetic flux also will be 0. No area, no magnetic flux can be associated. So, final magnetic flux is 0 upon R as it is. And what is this capital N? Total number of turns. They have not given number of turns, they have given single ring only, and for that we should take number of turn only 1. Put N equal to 1, so it is now A into B upon R, A into B upon R, correct? This is giving you induced charge, okay? Read now number 15. Read it? Look, initially what is done? There is a coil, there is a magnet. Initially coil is kept at rest and magnet is moved with velocity v towards the coil. At that time we get induced EMF capital E. And now what is done? That along with the magnet, now this coil is also moved towards the magnet with the same speed. So, now the distance between coil and the magnet will be getting decreased with the double rate, because the relative velocity between two has become doubled. How? I am showing you. Come on. Velocity of coil with respect to magnet. Velocity of coil with respect to magnet. Let it be V dash. It is nothing but velocity of coil minus velocity of magnet. Velocity of coil I have taken V minus velocity of magnet. Because magnet is moving opposite to coil, its velocity should be taken negative. So, I am putting minus V, minus minus plus, V plus V, that is 2V. Okay. So, you can see this velocity is now getting doubled. Now, tell me, if in the relative motion, if the velocity becomes double, then time rate of increase of magnetic flux associated with the coil will also be doubled. And you know from Faraday's law, E varies as d phi by dt. When this is becoming double, these also will be doubled, correct? Fine. And now d phi by dt is proportional to V. E proportional to d phi by dt, d phi by dt proportional to V, A proportional to B, B proportional to C, then you can write A proportional to C. You can write na? Okay. I repeat, A proportional to B, B proportional to C. So, definitely you can write A proportional to C. Similarly, E proportional to d phi by dt, d phi by dt proportional to V. So, now directly you can write E proportional to V, E proportional to V, correct? So, when relative velocity compared to initial condition, now the relative velocity has become double. Because this has become double, naturally this also will be double. So, earlier EMF was E, now it will become 2E, correct? Fine. Read number 16 now. Come on. Magnitude of induced EMF given by formula E equals to BVL. Just take d by dt on both the sides. So here it is dE by dt, B and L they are constants. When you take d by dt here, it is dV by dt, correct? Fine. Now B into L as it is, but what is this dV by dt? Time rate of increase of velocity, because here they are given acceleration, okay? Now this dV by dt can be replaced by acceleration, okay? Now because this acceleration is positive, this will give you time rate of increase of induced EMF. Time rate of increase of induced EMF, fine. Now this B, magnetic field, they have given 2 Tesla. What about length? Sorry, magnetic field is given to you 2 into 10 raised to minus 2 Weber upon meter square or Tesla. What about length? They have given 5 centimeter. Convert it into meter, multiply 10 raised to minus 2. What about acceleration? They have given 2 meter per second square, correct? Fine. Simplify, answer is 20 into 10 raised to minus 4. Because you are finding EMF upon time, unit will be volt upon second. Volt upon second. If you take second up, then volt into second inverse, correct? Read number 17 now. Come on. First, let us find out self-inductance of given inductor. L equals to capital Phi upon capital I. Capital Phi is total magnetic flux. It is N into small phi upon I. What about number of turns? They are given 100. Small phi is magnetic flux linked with 1 ton, which is 5 into 10 raised to minus 3 Weber upon I. What is I? Current, which they are given 2 ampere. Simplify, answer is 0.25. Unit of inductance is Henry. And now they have asked the magnetostatic potential energy stored in an inductor. Its formula is UB equals to 1 by 2 Li square, correct? 1 by 2 as it is. What about L? We have found out 0.25 Henry. Current is 2 ampere, it's a square. Simplify, answer is 0.5. Unit of energy is joule, correct? Go for reading number 18. Look, induced charge is given by formula Q equals to phi 1 minus phi 2 upon R. Capital Phi 1 is initial total magnetic flux, is given by formula N into small phi, but initially, so I am writing small phi 1. Similarly, capital Phi 2, it is N into small phi 2 upon R. Now this N I can take out. Inside the bracket phi 1 minus phi 2 upon R. Phi 1 minus phi 2 upon R, correct? Now actually this is the correct answer, but in the textbook they have given the answer in which you will find these terms given in reverse order. They have not given phi 1 minus phi 2, they have given phi 2 minus phi 1. Actually speaking, this answer is correct, because when we had obtained this formula of induced charge, we started with Faraday's law of electromagnetic induction with negative sign, including Lenz's law. E equals to minus L d phi by dt equals to minus N d phi by dt, correct? Because we had started with negative sign, we are getting this answer, okay? If you want textbook answer, you should start with plus sign, E equals to plus N d phi by dt, and then you will get this answer, given in textbook. I repeat, this answer is perfect because we have obtained this answer using Faraday's law of electromagnetic induction. E equals to minus N d phi by dt, including negative sign, okay? Fine. Now in the examination, suppose this is also given in the option, and the option which they are given in the textbook is also given. Suppose then this is perfect answer. Okay, fine. Now read number 19. Come on, read it. We are given a straight long wire through which I amount of current is passing, and in the neighborhood of this wire we have a loop. Okay, fine. Now because of this current passing towards right hand side, you can expect magnetic field, magnetic field lines associated with the loop coming out perpendicularly from the plane of the figure, because if you hold this current carrying wire in your right hand palm such that thumb should be pointing in the direction of current, then these fingers are taking turn this way, correct? Means perpendicularly outside. So right now we have got some magnetic flux in which magnetic field is induced perpendicularly out from the plane of the figure. But what have they said now? That this current decreases with time. If this current decreases with time, then what will happen? Here magnetic field also will decrease. So if magnetic field decreases, right, then induced EMF and hence induced current should be flowing in such a direction whereby they can oppose the decrease in magnetic field. If decrease in magnetic field is to be opposed, then magnetic field should be increased. So this induced current should flow anti-clockwise. Then only it will produce its own magnetic field perpendicularly outside. This is the current which we are passing, that also produces magnetic field outside, and induced current will also produce magnetic field outside. In short, perpendicularly outward, that magnetic field will increase. If it has to increase the magnetic field perpendicularly outward, then this induced current must flow anti-clockwise. When we view this figure from front side, this induced current must flow anti-clockwise. Okay. Now in examination, they may give that current is increasing with time. If this current is increasing with time, then it will increase the magnetic field perpendicularly outside. Then induced current should flow in such a manner, in such a direction, such that the increase in magnetic field should be opposed. To oppose the increase in magnetic field, the magnetic field should decrease, and for that case, the induced current should flow clockwise so that it will produce its own magnetic field inside. The current passing through this wire produces magnetic field outside. So because they are opposite, they will subtract each other. Ultimately, resultant magnetic field will be less. Okay. But right now this current is decreasing with time. At that time, induced current will flow anti-clockwise. Okay, fine. Read now number 20. Come on, read it. Out of the 4 situations, the condition number 1 is such that in which both the loops are parallel to each other, their planes are parallel, and because of that what happens? When current passes through this loop, magnetic flux is linked with this loop, but with maximum amount. When current passes through this loop, maximum magnetic flux is linked with this loop. I mean to say, whether you find out phi 2 upon I1 or phi 1 upon I2, in both the cases, the numerator which gives you magnetic flux is maximum. When numerator is maximum, that ratio, that is mutual inductance, also will be maximum. So in this condition, come on, mutual inductance is maximum. Okay. Come on, read now number 21. Come on. V equals to Vm sin omega t. That is the formula of alternating voltage. You know what they have given in the statement? At time t equal to 0, at time t equal to 0, they have given voltage 0. So we must use this formula, V equals to Vm sin of omega t. Fine. Now Vm as it is, sin as it is, omega as it is. Now they want this voltage at the end of how much time? Time they have given pi upon 2 omega. Correct? Now this omega omega will cancel. Sin pi by 2 is 1. 1 into Vm, that is Vm. So I am getting answer V equals to plus Vm. Okay. In the textbook there is a misprinting. They have written this M together with V. Actually this M is a suffix, indicates maximum voltage. Got it? Thank you.